I would like to thank the organizer for inviting me to give a talk to this virtual meeting, a new experience for me, and I hope that the message can reach you clearly as in the conventional talk. Before starting, a short introduction of myself. I am a senior scientist at the Institute of Food Science, which is part of the National Research Council. Here is my conflict of interest disclosure statement. I declare no conflict of interest. And before starting, let me acknowledge my research group at the Institute of Food Science, who did the work, especially Maria Russo and Carmela Spagnuolo, and all the other collaborators in-house, in Italy and abroad, that in these years contributed to the data that I'm going to present. This is the overview of my presentation. I'm going to discuss with you the role of polyphenols as anti-cancer agents, a role that recently has been seriously debated. In the second part of my talk, I will share with you our experience on the anti-cancer activity of a specific flavonoid, quercetin, in a specific form of cancer, chronic lymphocytic leukemia. As you know, flavonoids are the most abundant and representative class of polyphenols, and even a larger group of compounds present in fruit and vegetable, characterized by a similar structure with one or more aromatic ingredients and several hydroxyl groups. Polyphenols and flavonoids include the well-known compound largely present in the current literature for being protective against several forms of cancer. All of us that work in the field has a slide like this that I like to call the pharma market, because it is easy to pick a specific type of food, apple, berry, tea, and identify a key molecule responsible for anti-cancer activities, at least in the in vitro model. Why all this fortune for polyphenols? There are tons. And as Barry Halliwell used to say, sometimes science follows fashion. And this was a very productive fashion, considering the large number of different compounds present in nature that could be investigated by a single scientist. In fact, it is to demonstrate in cell culture that this compound can act as blocking agent in carcinogenesis, suppressing the transformation of pro-carcinogen to carcinogen, and many flavonoids can do this, or acting as suppressing agents, interfering with the processes that regulate cell growth, such as induction of apoptosis, cell cycle arrest, and so on. However, to better understand how the field evolved in the last 20 years or so, it is useful to shortly present the historical environment and some key scientists that gave their imprint to the field. At the end of the 80s, Steve Di Felice coined the term nutraceuticals, meaning a food or a part of food that provides medical or health benefit, including the prevention and or treatment of a disease. In the following decades, Mike Spohr defined the new field in cancer research known as chemoprevention, referring to the use of pharmacological to the use of pharmacological or natural agents able to block, arrest, or avert the progression of pre-malignant cell to malignant phenotype. Last but not least, in the same years, Barry Halliwell, a guru in the antioxidant field, declared that our endogenous antioxidant defenses are inadequate to prevent oxidative damage completely. Therefore, sources of dietary antioxidant may be especially important to us. We must say that 10 years later also, he significantly changes his mind and his opinion on this issue. As a consequence, the entire field remained under the umbrella or the large umbrella of the so-called antioxidant hypothesis or the free radical theory, well supported by epidemiological studies, suggesting that paying attention to implement our diet with antioxidant-rich food or supplement that of course contain a significant amount of antioxidant compound like polyphenols and others, we could prevent cancer and other degenerative disease. As indicated in important study like this from Giovannucci group. To look into the number of these and other studies, it has been observed a 3-4% reduction in the relative risk of total cancer for each 200 grams per day increment in intake of fruit or vegetable and fruit and vegetables combined, while in the nonlinear model shown on the left, they observed a 13 reduction in the relative risk of total cancer for an intake of 500 grams of fruit and vegetables compared to 0.40 grams per day. Recently tried to give our contribution to the ongoing discussion in cancer prevention by polyphenols, including of course flavonoids, with this review article where we critically and autocritically, I must say, expressed our opinion, which is summarized here. The controversial contradictory issues related to the pros and cons on the use of polyphenols against cancer reflects the confounding assumption that cancer treatment and cancer prevention may overlap. Summarized in tables 1 and 2 of this review article, based on observational and interventional studies published in the last 10 years, where polyphenols as a single compound or in mixtures has been tested against different type of cancer, or based also on interventional study retrieved from different databases, including of course CancerGov, the efficacy of polyphenols against cancer resulted uncertain, null, negative, or no significance. These findings are corroborated by more recent analysis, such as the EPIC study shown in this article, that established no significant association between increased consumption of fruit and vegetables and reduced risk in 9 different forms of cancer. Similarly, moving to the specific effect of polyphenols, this highly cited meta-analysis of prospective case control study published by the Daniele Del Rio group showed only for isoflavones a significant association with the decreased risk of lung and stomach cancer, while total and or individual classes of flavonoids showed only promising but not conclusive result. Totally changed when we analyze data summarized in table 3 of our above mentioned recent article, where it emerged as expected in preclinical models such as in animal, essentially mice and rats, genetically programmed to develop cancer or where tumors were experimentally induced, the anti-cancer effect of polyphenols was not only robust, indicating both a chemopreventive and chemotherapeutic effect, but unexpectedly specific phenols compound and or their derivatives were able to kill cancer cells throughout mechanisms that involved the production of ROS, of reactive oxygen species, not their reduction. In other words, they worked as pro-oxidant instead of antioxidants. To increase the entropy of the field came this controversial and provocative paper from Jim Watson. According to him, dietary antioxidant or supplements, by destroying free radicals, may have caused more cancer than they have prevented. This because he thinks that cancer cells can be killed by increased reactive oxygen species levels, and the cancer-resistant cells are at least partially sustained by the capacity of key oncogenes such as MYC, RAS, and RAF to increase antioxidant defenses via, for example, the KEEP NRF2 system. Supported by several elegant papers, I will report here only one. In this case, the Kaplan-Meier plot shows that the survival of BRAF mutant mice was reduced, not increased as perhaps we expected, by treatment with natural vitamin E or synthetic and acetylcysteine antioxidants. We end up with the following model. We cannot exclude a priori that polyphenols can have both application as nutraceuticals and or functional food, which means low doses administration for a long time, or as a drugs, that means high doses, potential toxicity, limited administration. Both applications, of course, present weaknesses, as an example, the low bioavailability of this compound, as well as strengths, the capacity to be pleiotropic compound. This means to hit several cellular targets. It is important how we approach one or the other intervention, and of course the choice of the cellular model employed must be different. We summarize three key aspects of the study design, which are listed here. A very careful selection of the cellular model, the quantification of the real uptake of the tested compound or its metabolites, the identification of the very early target of the selected compound, possibly within minutes from their uptake. We applied these guidelines to the study of quercetin, and we are getting into the second part of the seminar, of the presentation, in the adjuvant therapy against a specific form of cancer, chronic lymphocytic leukemia. Quercetin is one of the most abundant flavonoids in fruit and vegetables, with an uptake of about 50 grams per day, 50 milligrams per day, but in many cases, after supplementation of a diet particularly rich in quercetin containing food, this value can go up of 5-10-fold. It is present in several fruit, vegetables, and beverage, and you see here the relative concentration. To make a long story short, we don't have time. I mean, we demonstrate in a large number of cell line that quercetin per se is not apoptotic, but it is pro-apoptotic. In other words, the treatments with the single agent does not induce cell death, does not kill cancer cells, but in association with the conventional chemotherapeutic agents, quercetin contributes to enhance the effect of the let's say conventional drugs. That's why pro-apoptotic. And we focused our attention on a cell line that showed the resistance to treatment with the chemotherapeutic agents. We also demonstrate that quercetin, this capacity of quercetin is specific, because long time ago, this is an experiment done several years ago, because other flavonoids did not show the same activity. And here you see just an example of what I was saying. Large part of this experiment has been done by Maria Russo and Carmela Spagnolo in this direction. Here you see the treatment with that receptor-induced recombinant trail. Here you see the treatment of cancer cells with this is the control. These are you see the resistance to the pro-apoptotic agent. No effect of quercetin per se, but when you combine it together, you see you can measure a massive apoptosis. Then we moved to a, let's say, more physiological model, chronic lymphocytic leukemia, for several reasons that you can read here, are listed in this slide, but mainly because CLL is considered an heterogeneous, still an incurable disease. Most patients become resistant to common chemotherapeutic drug, among these fludarabine, and B cells are normally resistant to that receptor-induced apoptosis. At that time, we were concentrated on the effect of that receptor inducers. Our hypothesis was to test in an ex vivo model represented by B cells taken from patients affected by chronic leukemia, and this was done in collaboration with the local hospital, thanks to the colleague Silvestro Volpe that give a strong support to this part of the work. The idea was combining, let's say, canonical anti-cancer drug used for example, fludarabine in the treatment of chronic leukemia, or innovative drug like ABT737 with the quercetin, we could induce apoptosis in cells in that form of leukemia that showed a resistance to the single treatment. I will show you data only on ABT737 for lack of time, but it's an example. But the same situation was also proved with other therapeutic combination. ABT737 is a BH3 mimetic agent. It per se is able to induce apoptosis in chronic leukemia, as you can see here. This compound has a specific inhibitory activity against some members of the BCL2 family of anti-apoptotic proteins, but it is less effective against other, such as MCL1. And MCL1 is one of the anti-apoptotic member of the BCL2 family that is increased in leukemia, in chronic leukemia, and induce resistance. As you can see here, all these numbers present patients, okay? In the combined treatment, always here, the third bar for each group, always in the combined treatment, ABT737 plus quercetin, we could measure not only an increase in cell death that results to be an increase in apoptosis, measuring in this case by annexin 5 positivity, but this combination was also synergistic. It's important to show that on peripheral blood cells there was no effect, indicating that quercetin had a specific, the association between quercetin and ABT737 was specific, is more effective for the malignant. The hypothesis was that why this? Because we supposed that ABT737 was able to inhibit some member of the BCL2 family, probably was not enough to induce apoptosis, but ABT737 was not effective on the pathway PI3 PAKT that activate MCL1, and probably quercetin was insisting on the inhibition of this. However, as those working in the field knows very well, working on B cells isolated from patients is very difficult. Then we switched, thanks to the availability and collaboration with Anders Rosén from Sweden, we took advantage of a new cell line, HG3, established in vitro by Epstein-Barr infection, Epstein-Barr virus infection. This was an immortalized B cells isolated from a patient affected by chronic lymphocytic leukemia that maintained the main feature of the leukemia, but was with big advantage to be used. In this case, the combination was synergic with a combination index. And also in this cell line, we demonstrate that treatment with quercetin was able to inhibit phospho-AKT, as you can see here, the active form of AKT kinase, and was also able to download the expression of MCL1. So demonstrate that quercetin, confirming that quercetin was insisting on this pathway, leading to the inhibition of and reduced expression of the anti-apoptotic factor. And we thought that probably this effect on the inhibition of the PI3 AKT kinase by quercetin was due to the capacity of the molecule to inhibit directly PI3 kinase. We demonstrated, as you can see here, in fact, treatment of G3 cells with quercetin in 1 hour of treatment reduced by 50% the activity of the enzyme, and the reduced activity was not due to change in the expression of the catalytic subunit. I would like to stress, you will understand in 1 minute why, that the inhibition occurred in. We also demonstrated that the quercetin was present after 2 minutes of treatment inside the cells. But what was puzzling us is this piece of information, that the treating cells with the quercetin, we noted that the inhibition of phospho-AKT and the reduction of the expression of MCL1 occurred in 0.5 minutes, very fast, and before the inhibition of PI3 kinase. Suggested that probably other target of quercetin insisting on the same pathway could be present. To make a long story short, and we tried several of them, we concentrate our interest, our investigation on one of these, CK2. CK2 is one of the activator of PI3 AKT pathway, since it inhibits P10, that is an inhibitor of the activation of phosphorylation activation of AKT. There is also a rationale in CK2, because CK2 is involved in CK2 is casein kinase 2 is involved in for several aspects in the resistance of chronic leukemia to treatment. First of all, because as I said, inhibit P10 phosphatase, and also it was demonstrated that the association between a canonical chemotherapeutic drug against CLL, such as fludarabine, in association with an inhibitor of CK2, was able to improve, cell death and induction of apoptosis. In fact, we demonstrated that quercetin in vitro, working on the pure enzyme isolated from bovine, was able to inhibit the enzyme. And finally, as we expected, the treatment of the stem cell line, G3, in the presence of quercetin, very soon, at 0 time, inhibit more than 50% the activity of CK2, and the quercetin was even more effective than a well-characterized inhibitor, chemical inhibitor of the same enzyme. Also, in this case, the inhibition was due to effect on the enzyme and not on the expression of the catalytic subunit. So this is the last couple of slides. We can conclude saying that we were, at least in this model, chronic lymphocytic leukemia, we were able to demonstrate that quercetin is present inside the cells, and we identified the direct substrate of quercetin, in this case at least two kinases, CK2 and PI3 kinase. The inhibition of the activity of this kinase block the pathway leading to the increased expression of an anti-apoptotic factor that causes resistance to apoptosis in chronic leukemia, and together with parallel inhibitor activity of ABT737 and other BH3 mimetic on other member of the BCL2 family, it was possible to justify and explaining the enhancing effect of the combined treatment between quercetin and the BH3. These are the conclusions that I summarized here. Quercetin sensitizes synergistically human malignant cell lines and B cells isolated from patients. At least in CLL, quercetin targets primarily protein kinase at least 2, which positively regulated the PI3 AKT MCL1 pathway. And the quercetin cytotoxicity on normal peripheral blood cells is acceptable. Considering all this information and this other piece of data that the phase 1 clinical trials in human established the recommended dose of 2.5 grams for 70 kilograms intravenously weekly, all this data indicate the potential therapeutic use of quercetin against chronic leukemia. I'm finished. Just acknowledge the agency that help us with their financing support in reaching the result that I showed you. Thanks very much for your interest.